Okay, technically today is 4.2.2, and I'm doing a little bit of review of 4.2.1. And that was things like, well, actually, this is even 4.1 stuff. 3 pi over 2 is right there. So this one's kind of gotten sloppy. I'm going to erase the stuff that doesn't matter. That, and I don't even need that. Really, that's the spot for 3 pi over 2. Now, you can't draw a reference triangle for that. I'm going to give you one now that you can draw a reference triangle for. You ready? 2 pi over 3, or 2/3 pi. Draw the ray, but then drop to the x, whichever, I shouldn't say drop. Go to the x-axis, and then you'll have created a triangle with the x-axis. This one, I want you to compare with the person across from you. We're going to do these 2 rows across. This row is going to be complicated, so pay attention. It's you 2. You can see a diagonal. You 2. You 2 are comparing. You 2 are comparing. And you 2 are comparing. Okay? And then over this way, we're going to go diagonal again. Pay attention here. You 2 are comparing. With me. You 2 are comparing. You 2 are comparing. You 2 are comparing. And you are going to show it to me. And I'll tell you if you're doing it right. Okay? Now show it to the other person and see if you're the same as them. This was 2 pi over 3. What'd you think? I agree. Good. Now, I never said to, so now you can put it in there. What is the reference angle? All right, so this was like, here's how I'd think of it. That's like, no, that's not 1 pi over 3. That's about a pi over 3, which hopefully you've memorized by now is about 60. This would be 2 pi over 3, which is about 120. Okay? Now this reference angle that's left is this angle right there. So if this was 2 pi over 3, the reference angle for it in radians would be 1 pi over 3, or pi over 3, also known as 60 degrees. Raise your hand if you're comfortable with that part. Okay, good. Then yesterday I just taught you 6 trig functions. Yeah, I knew 3 of them, sine, cosine, tangent. See if you can just recall the right ones that go with them, the flippin' sisters. There's this and this and this. 3 new functions. One of them goes with sine, because all you have to do is take your answer for sine and flip it. One of them goes with cosine and one of them goes with tangent. You may remember that I said that S goes with C and C goes with S. S goes with a C function and the C goes with an S function. And then tangent's the only one that seems logical to me. Tangent and what's the other one? Cotangent. Okay. And sine goes with CSC, and that's cosecant. Cosecant. And the last one is cosine goes with secant. All right. There we go. Those are the big 6. So if I give you any one of them, you can figure out all the others. Because what I'm really telling you is 2 sides of a triangle. So if I say sine is 1 over the square root of 2, then you can go make a triangle for that. Figure out the 3rd side. Let me see if you can remember this one. This is a triangle. Sine, I can pick any angle to be my angle except for the 90, so I ignore this spot. But the other 2, I could have picked either one. I'll just pick the one closest to me. So then sine is opposite of hypotenuse. You see opposite, here's the hypotenuse. Do you remember what the other one is? All right, you'd have to do a squared plus b squared equals c squared. Or if you remember the shortcut, you could go like this. This is the square root of that squared minus that squared. And the square root of 2 squared is 2. Minus 1 squared is 1, which makes 2 minus 1 is 1. And the square root of 1 is 1. That side's just 1. Do you remember a triangle that had sides 1, 1, and the square root of 2? That's the 45, 45, 90. Very good. All right. Now, it's appropriate time for us to remember that 45, 45, 90, because that's the thing you're going to be using a lot today. If it's 45, 45, 90, this is true of any 45, 45, 90, its side ratios would be, these sides are the same. So if it was 10 and 10 or 9 and 9, but they're the same, I'm using a 1. This other side will be whatever that side is times the square root of 2. So 1, 1 and the square root of 2. That is a super important triangle. You're taking notes right now. I would put a star next to these notes. I would do something to indicate this is an important thing. You need to know that formula or that triangle. That's one of the big ones. The 1, 1 square root of 2, 1. That's for the 45, 45, 90 triangle. Okay, now there's another one. That's the 30, 60, 90 triangle. And do you remember that has a 1 in it? And anybody have another idea of what's another one in it? All right, this is one that's your forgetting curve. I know you knew it in your geometry class. This is for sure taught in there. They use it a lot. It's just been too long. It's okay, you're human. That's what happens if you go too long without using something. And that's normal. Okay, but we got to get it back in your head, and you got to be good at it. Like this got to be like easy stuff. Okay, so memorize this, please. This one's 1. Obviously, it's the shortest side. So if anything is going to be 1, it'd probably be that. The longest side is the hypotenuse, and that's double the shortest side. So that's 1, that's 2. Oh, I want to take a stab at the third one. Remember it? Root 3, very good. Now, if you hadn't memorized it like he did, which is awesome, then you'd have to go back and say this. Okay, square root of this one squared minus this one squared. And that would be 4 minus 1, which would be 3, square root of 3. I'm giving you a shortcut. Granted, if you want to, you can go a squared plus b squared equals c squared. Stick the numbers in and solve. It's just I'm showing you a way faster way than that. And the fastest way of all is just memorize it. Square root of 3. All right. Those are going to be two super important formulas triangles for later today. Okay, back to the problem we were doing. Sine was 1 over the square root of 2. And I went and looked through and remembered that basically that triangle right there is the same triangle we're working with. A 1, 1 square root of 2 triangle. I'll circle this to just kind of keep the symmetry going there. Okay, so then let's cosine within this angle. Cosine then is adjacent over hypotenuse. It's weird, but it's the same exact thing. 1 over square root of 2. And tangent is TOA, opposite over adjacent. 1 over 1. Opposite over adjacent, 1 over 1 is 1. I could put 1 over 1 if it would make you feel better, so they'll all be fractions, but 1 over 1 is 1. Okay, now the cosecant, secant, and cotangent, I call them the flippin' sisters for a reason, because you can just flip those over, and now you get your answers. Root 2 over 1, which is the same as root 2, of course. Root 2 over 1, same as root 2. And the last one's 1 over 1, so I flip it to 1 over 1, and it's still 1. Okay. So how are we using this now? Next, what's the new thing for today? Oh, wait. There was one other thing yesterday that I want to make sure you remember. Let's say you had this, and this side is like 3, and this side is, well, actually, let's say I don't even know the other side. I want to figure out this side, and I knew this was a 60-degree angle. How can you figure out the other side? I didn't talk about this in class much. It was on your homework, and hopefully you could have checked your answers. But if you would have watched this video that I recorded, I actually addressed this in the video last night. So if there's ever a situation like that where you're like, oh, he didn't say anything about this in class, you can go to the end of the video that I made, and if I notice that I missed something in this hour, I'll pick it up in a different hour, and then when I record it, I'll record the video in there. So I'm just saying, not that you had to, but it's a resource for you. You could have watched the video. All right, you use sine, cosine, or tangent, of course, and if I'm looking at it from this angle's perspective right here, what I have is the opposite and not the hypotenuse, but the adjacent. Which function does opposite and adjacent? You gotta go SOHCAHTOA. Which one has opposite and adjacent in it? Tangent, see? Right there. So tangent of the angle equals, everybody should be writing this down right now, tangent of 60 would equal, well, what is TOA? Tangent, opposite over adjacent. Opposite is n, over adjacent is 3. Tangent of 60 is equal to n over 3. Have I got n alone yet? Then ask yourself, what should I do to both sides of the equation so that n will be alone? Yes? Multiply by 3. So I'm going to times by 3 here, and times by 3 here. And then this cancels this. And now I know what n is. N is equal to 3 times the tangent of 60. All right. Do another one like that. This time it's a 30-degree angle. And this side here is 7. And this side here, I don't know. I'm going to call it an X. Figure out what function, sine, cosine, or tangent, you want to use. Set up the little, like, let's say you decide on tangent. Tangent of 30 equals this over this. And then just solve it for x. Except I'll give you a hint, it's not tangent. I'm going to pause for a second while I give that one a shot. So here's how I think my way through this. All right, from this angle's perspective, I know it's got to be something of 30. I really should have put a degree symbol there. Lose half point. Anyway, opposite and hypotenuse. So if I'm going to use opposite and hypotenuse, maybe I should write this out. The one that uses opposite and hypotenuse is that one. So it's sine. Sine of 30. How many of you guys use sine? Good. And it's equal to, sine is opposite of hypotenuse, 7 over x. Now this is more of a pain in the butt to solve for. To get the x alone, first thing, do you remember, last semester we spent a lot of time clearing fractions. This has got a fraction in it. We got to fix that. We multiply by the denominator. If I times by x, I multiply by the denominator. Now I don't have a fraction anymore. Now you should try to get the x alone. So all I got to do is divide by sine of 30. Final answer, x is equal to 7 over the sine of 30. Now it's a little messy. There it is, 7 over the sine of 30. Now, that's what you had a couple problems at the end of your assignment like that. Okay? And you're expected to know that kind now. Precalc is tough. You just keep moving on faster and, not faster and faster actually. It's just one new thing every day. So all I've done is review with you up to the point where theoretically you're supposed to know how to do that up to today. Now, what's the new stuff for today? New stuff for today basically is problems as simple as this. What's the sine of 30 degrees? Except they're not going to say 30 degrees. What's the same as 30 degrees, but we've been making you practice over and over again? Pi over 6, very good. So here's a typical question for today, is sine of pi over 6. And right away, if I were you, because we memorized these triangles as the 30, 60, 90, or the 45, 45, 90, I would have them, honestly, if you wanted to save time on today, I know you probably can't do this with an iPad, but you could have it on a separate sheet of paper off to the side. We're going to be referring to this over and over and over again. If I'm going to need the 30, 60, 90 triangle, which is this guy, 1, 2, and the square root of 3, and the other one, 1, 1, and the square root of 2, and that's the 45, 45, 90. Okay, I got to use those triangles to get these answers. So do you get that really pi over 6 is 30 degrees? So really they asked me, what's sine of 30? And now I go over and find a 30. The only 30 that's here is right there. And then all I have to do is, sine is opposite over hypotenuse, right? What's the opposite? From the 30, what's the opposite? 1 over what's the hypotenuse? So sine of 30 is a half. Sine of 30 comes up so much, it'd be worthy of just memorizing. So sine over 30 is a half. You're going to see that in so many situations. Mark my words, I'm going to come back to this thing at least 5 times this month. We're going to have problems that have sine of 30 in it. It's just handy to know it. All right. I wouldn't have you memorize all of them, but that's a biggie. All right, so instead of sine, let's say I do tangent of, instead of pi over 6, let's go pi over 3. Hopefully you can in your head go, oh, I know pi over 3, it's this. If you don't, you have to go off to the side, do a little calculation, and figure out how many degrees that is. And once you know, oh, that's this angle, you'll be able to find the tangent of it. It's just a fraction. It's like opposite over adjacent in one of these triangles that you're seeing. In a moment, I'm going to ask you to compare with the person next to you. It's okay to say, can you show me how? Okay, because I understand you might not know. But what's not okay is just go, oh, I didn't know. Okay, because if you don't know, you need to ask them. And if both of you don't know how to do it, it's okay. I'm going to show in a second how to do it, but hopefully one of the two of you knows how to do it. Okay, I'm going to pause for a second. Compare with the person next to you. If you don't know, ask them to show you. Okay, I heard some really good teaching, and I really appreciate that. It's so good for kids to learn from somebody other than the teacher, because you got to get that feeling that I'm not the only one that can show you how to do this. All right, pi over 3 is 60. That's one that I hope you just had memorized. Again, if you didn't know, go off to the side, multiply it by 180 over pi. That works. Cancel, cancel. You go, oh, 3 goes in here, 160, and then 60. Okay, so tangent is 60. Find the 60. There's only one on the whole list. There it is. Tangent of that thing, tan is opposite over adjacent, TOA. If you want to like put a little helper thing, it reminds me of the Homer Simpson episode with helper monkeys. It's my little helper monkey. Anyway, so opposite over adjacent. So the opposite sides, root 3. Adjacent side is, oh, that I almost picked the 2. That would have been the hypotenuse. That would have been bad. The 1. Square root of 3 over 1, which is the square root of 3. Raise your hand if you had that one right. Okay, good. All right, so here's where it gets a little trickier. Cosecant of pi over 6. What? You haven't got those memorized. You can't use SOHCAHTOA for that, can you? All right, I'm going to go back to that other slide because I had those triangles. You see why I think it'd be smart to have them out? Because I'm going back to them all the time. Cosecant of, what did I say again? Pi over 6. Pi over 6. Okay, first thought is, what's pi over 6? 30. So cosecant of 30. Second thought is, I don't know how to do cosecant. So I'm going to do its flippin' sister. Remember how S goes with C and C goes with S? Cosecant goes with what? Sine. So if I want to change cosecant of 30 into sine, I have to go like this. 1 over cosecant of 30 would be obviously different than cosecant of 30. But if I change cosecant of 30 to 1 over sine of 30, do you get now I just need to figure out sine of 30? And then I'll flip it, because that's what putting 1 over something does, is flips it. Okay, in case you weren't here in my first semester, we practiced this a lot. 2/3 divided by 4/5. I had people do this in what's called my top 20, and it's just a reminder of some basic skills. If you forgot how to do this, you got to be reminded right now. 2/3 divided by 4/5 is the same as 2/3 times, and you flip the bottom one over, 5/4. I don't know if you remember doing that back in middle school, but 2/3 divided by 4/5 is like 2/3 times 5/4. What did I do? I changed it to flip and multiply. So that's what you're doing here is 1 divided by, this answer is going to be a fraction. Did I say this is going to come up multiple times? Mm-hmm. What is it? What's sine of 30? Did you memorize it yet? 1/2. Good. Remember I told you this is going to come up a lot? If in case you don't know that so quick, you go over here, sine of 30, it's that one. Sine's opposite of hypotenuse, so 1 over 2. 1/2. This is 1 over 1/2 then, and I just showed you how to do that. You flip and multiply. So I got to go 1 times, flip it over, 2, so the answer would be 2. All I did is change 1 over 1/2. That causes you to flip it, and you get 2 for an answer. So the cosecant of 30 degrees is 2. Now, you can't even check that on a calculator to verify that you're doing it right because there's no cosecant button. Know what I'm saying? There's a sine, cosine, and a tangent button. What could you do? Well, you could do sine of 30 and then take your answer and flip it. Because there is no cosecant button. All right, let's do another one like that. Secant of pi over 4. First thing, what's pi over 4? You got it memorized yet? 45. Good. So it's really secant of 45. But I wouldn't want to do secant of 45. I'd instead rather do 1 over the flippin' sister. S goes to C, C goes to S. Remember this one? Cosine of 45. Now I got to figure out cosine of 45. Oh, I wish I had those triangles. I guess I can recreate it quick. 45, 45, 90 is 1, 1 square root of 2. Again, a lot of stuff to memorize in this class. You need to be on, like, those things I tell you, memorize it. I'm serious, because then we're going to need more stuff memorized the next day. All right. So cosine of 45, then I can pick either one of the 45s and it'll give me the same answer. So don't worry about which one to choose. Either one. Cosine of that, adjacent over hypotenuse. Adjacent, hypotenuse, 1 over square root of 2. So this part right here is really 1 over square root of 2. And when I put 1 over that, it makes it flip. The answer is the square root of 2. How many of you would have had that one right? Okay, now let's do one more like that, all by yourself, and you're going to check with your partner. This one's going to be, what's the one I haven't used yet? Cotangent. Cotangent. Oh, I have to repeat one of the angles. Let's go with the pi over 4. Find cotangent of pi over 4. Do it one little step at a time. Math is best done one little step at a time. Find something you know, replace it. Something else, replace it. Draw a little triangle. That's a helper triangle. And when you're done and you think you have it, compare with the person next to you. If they're different, try to decide who's right. Get some help. I'll pause for a second. Okay, please, if you haven't already, show the other person. And if you're stuck, just say I'm stuck and ask for help. If you're both stuck, I guess you'll have to wait a minute. But if you notice the people behind you are both stuck, please help one. Okay, Mr. W, tell me how you start.
Take 1 over the tangent of pi over 4.
Well, what's pi over 4? That's how I'd start. Okay, and then I'd take, I agree, 1 over that. And instead of cotangent, you're going to use what? Tangent of 45. Very good. Okay, now I need a triangle. 1, 1, square root of 2. And that's the 45, 45, 90. And then I need tangent of 45, so I go find that. Tangent's opposite over adjacent, 1 over 1, which is 1. So this whole thing is a 1. And then it's just 1 divided by that. What's 1 divided by 1? It's 1. So the cotangent of pi over 4 is 1. Raise your hand if you had that one right. Awesome. Okay. Now you're ready to go backwards. If the sine of 30 is 1/2, we've established that one pretty well. Again, I've got a picture for it, 2 if I need it. 1, 2 and the square root of 3. Looks like that. Remember this one? Sine of 1/2, or sine of 30, sorry, is 1 over 2. We good with that? Then what if I said, what's the sine of what is 1/2? Do you get how, what do I need this time? Last time I gave you the whole thing. I told you the angle and I told you the side ratios. And with the problems we were doing were like this. They'd say sine of 30 and you'd have to figure out the side ratio. This time, they didn't tell me the angle. It's sort of like Jeopardy. They're giving you the answer to the question. The answer to the question is 1/2. So what was it? Well, this one's a really easy one because we practiced it. So what is the degree? 30. If I didn't know it, like if I give you a weird one, like square root of 3 over 2. How about we do that one? And I have to say, well, what do you mean? What I need is, I need what angle is that? So if it's got the square root of 3 and 2 in it, I know it's got to be from this triangle, right? Then the only question is, can't be the 90, is can it be 30 or 60? So you go up and you look at those two angles and you figure out the sine of which of them would give me root 3 over 2. 60. So sine of 60 is root 3 over 2. And you can just check yourself. Make sure you're really right. Okay, if I really do sine of 60, sine is opposite over hypotenuse. There it is. Yeah, that's it. All right, let's do another one. Let's say I had the tangent of some unknown angle is 1. First thing I'd want is the triangle that has opposite. Here's the first thing I'd do, actually. I'd make that 1 into a 1 over 1. You know, because I need two sides of a triangle, right? And do you get the tangent is opposite over adjacent, and they must both be 1 then? So then this triangle has 2 1s in it. That must mean it's this one. 1, 1, root 2. So now that makes it a lot easier. It's got to be in that triangle, and it can't be the 90. So what is it? Must be 45. And then if you think you got it, check it. See what the tangent of 45 really is. Tangent of 45, tangent's TOA, opposite over adjacent. 1 over 1, and 1 over 1 is 1. And so the tangent of 45 is 1, and so I answered it. 45 is the answer. Yes? Okay. Would you agree that the original problem said just 1? Okay, it said 1. So would you agree that on anything in the whole world, you can always write it and divide it by 1? That's why I did that. And the reason that I wanted to make it a fraction is because then I knew that would be an opposite and adjacent side, because that's what tangent is. And by getting 2 sides of my triangle, I'm way better off. So in the same kind of scenario, let's say I had a square root of 2. So I'm going to go cosine. No, I'm going to go with, I'm going to try cosine. Cosine of some angle is the square root of 2. First thing you should do is put that over 1. Then you got 2 sides of a triangle. Then you'll know which triangle you're in. Then you'll be able to figure out which angle it has to be. Just one little step at a time. Your first step is this. Yes, ma'am. Yes. You want to give me some collateral? Cell phone would be great, because I know you're not using it anyways. Oh man, my battery's out. You're going to have to move to the back wall and use this charger that has a plug. What the heck? There we go. Okay. First, draw a triangle that you know has a 1 and a square root of 2 in it. There's only one. 1, 1, square root of 2. The other one has a square root of 3 in it. Okay. So then, this one is the 45, 45, 90. And you can say then the cosine of that angle has to be, so what angle is it? Is really the question, right? And it can't be the 90, so what is it? 45. Now, what if this thing, the worksheet says, all answers must be given in radians? Now you got to do a quick conversion in your head. What is it? Pi over 4. All right. Yes, sir. You mean cosine? Okay, cosine is what? All right, ka, adjacent over hypotenuse. Let me see if you're right. He usually is, so let's see if I made something wrong here. Oh, interesting. Ka, adjacent over hypotenuse. Root 2 over 1, that's upside down. Interesting. So, then, is there any way to make it so that the hypotenuse... No, you're right. I've set up a flawed problem. You wouldn't have one like that. Don't worry. Good catch. It's upside down from what it should be. I should have had the answer be 1 over the square root of 2. All right. And yes, you could actually answer the question that I gave, but you wouldn't have known how to do it, so I apologize. That was a... Yeah, but the problem is that it's a problem is cosine. You can't change the problem to be secant. So I could have had a problem be secant of this is that. Or I have to change the problem to say 1 over that. So thanks for catching that. All right. Let's do one more that works out perfectly, so there's no concerning leaving you with a weird example. You know what? Let's do the first one on the homework. Everybody find the homework. It is 4.2.2, I believe. I'm double checking. Yes, 4.2.2. Take a minute, pull that thing up on your iPad. There's a lot here, and I don't think we need that much practice on these, so we're going to skip some. I'll tell you right now, why don't we skip 8, 10, 12, and 14. 8, 10, 12, and 14 can be skipped. All right. My first reaction on seeing pi over 3 is to change it to what? 60. So it's really sine of 60. Then, at the top of your worksheet, let's make 2 really nice reference triangles. Not reference triangles. They're kind of these classic triangles. The 1, 2, square root of 3, 1, which is the 30, 60, 90. And the other one, where these two are supposed to be the same, 1, 1, and the square root of 2, and that's 45, 45, 90. All right, so sine of 60. Well, there's only 160 in all my lists up there, so I'm looking at this angle right here. Sine of that, sine is opposite over hypotenuse. That's going to mean the square root of 3 over 2. That's it. Okay. Remember when we get to problems like, did I have you skip 6 or? No? All right. So 6 cosecant of pi over 4. Well, first of all, pi over 4 is really 45. So cosecant of 45, you don't want to do cosecant of 45. You want to do 1 over the flippin' sister of 45. So cosecant would be sine of 45. So that means you need to now figure out sine of 45 and then flip it. So sine of 45 comes from this triangle. Sine of 45 would be opposite over hypotenuse. If you ever need to use those little helper monkeys, go ahead. Opposite from the 45. I'm going to pick this 45. Opposite over hypotenuse. It would have worked out the same either way. Is 1 over the square root of 2. So my answer is 1 over the square root of 2. But I got to remember that I have 1 over that. 1 over square root of 2. And 1 over square root of 2 is really the square root of 2 over 1, but that's just the square root of 2. All right, now let's go to the back side of the worksheet and see how you do there. Find the acute angle that satisfies the given conditions. Did I mention this was going to come up a lot? Look at number 11. Got the answer yet? I do. 30. Done. But wait, there's more. Give your answer in both degrees and radians. So 30 degrees, and then you got to slap down a what? Pi over 6. If you haven't memorized those yet, get them memorized. Put them on flashcards. Do whatever you have to take. Do whatever you have to do to get those memorized. You know, this stuff's complicated enough that if you have to struggle through those little things, it gets really painful. All right. So this one. Well, the answer is root 3 over 2. I really wish I had those triangles, so I guess I'll draw them again. 1, 2, square root of 3, 30, 60, 90. And the other one I'll put here to save for later. Oh, I should draw that one with the sides being the same. 1, 1, square root of 2, 45, 45, 90. Okay. So now, which of those could possibly have root 3 and 2 in it? That one can. So if it's that one, and it's sine of it, sine of 30 or sine of 60, it's got to be one of those. What do you think? Well, take the 30 and try it. Does sine of 30 really equal that? No, we have that one memorized. Sine of 30 is 1/2. Sine of 30 is 1/2. That's not right, so it can't be the 30. Let me try the 60. Sine of 60, is that really root 3 over 2? And it is, so that must be 60. And then you got to remember to give it in radians. Who's got that one? Say it. Pi over 3, good. Okay, I think you get the idea. If you get to one like cotangent that you don't really know, automatically change it to flip it. And say, I'd really rather do 1 over cotangent, which will be 1 over 1. So then what is 1 over cotangent? That's the flipping sister of cotangent, which would be tangent. So that's really then tangent equals 1. If I figure out what makes tangent equal 1, that'll work. Like this one, I don't really want to do secant. So I'm going to do 1 over secant, and that'll be 1 over 2. What is 1 over secant? 1 over secant is cosine. I changed the problem. Now I can do it, because I know how to do cosine. So whenever you're stuck with one of those flippin' sisters that's new to you and you don't know how to do it, change it to its flippin' sister by putting 1 over it. Okay, I didn't mean to capture that. Oh, great. How do I delete that, I wonder? There we go. Okay. So, on the back side, this is all review. Nothing new here. Yay. So you should be able to find this. This is just a reminder how to do this kind of problem where if A is 20 degrees, they're saying that's 20. And they wanted the little a to be, that's really dumb. Oh, one of these isn't today. That's a, can't think of the name of that. Oh, that's alpha as opposed to A. Anyway, alpha is 20 and A is 12.3, which makes this 12.3. And they say find all its unknown sides and angles. So I'd redraw the triangle here and go, okay, so you're saying you know this is 12.3, you know this is 20 degrees, and you want to know everything else. So you got to use a little trig here, surprisingly enough. So what do I have? Oh, they must have given me one more side. Well, I can logically know that that must be 70 degrees. No, we're gonna have to use the calculator to do this. That's all. So we know. I'm gonna call this B and this C because those are the last two things I don't know. So I'm gonna do trig, either sine, cosine, or tangent. Well, I start with sine. Sine of 20 is opposite over adjacent. Opposite is 12.3 over adjacent would be B. So now I got B. Get how I can solve for B now? I just multiply by B on both sides and then divide by sine of 20. I'll have B. You just have to know what sine of 20 is. And if you're supposed to use a calculator, you can just type in sine of 20. If they wouldn't let you use a calculator, you'd leave it like that, sine of 20. So there's b, just have to solve it. You got to do some of the work here. And then why don't I do like cosine of 20? Cosine of 20, ca adjacent over hypotenuse. That's b over c. That doesn't really help me. B over c has both letters in it, so I better not try that. I better try tangent. Tangent of 20. Tangent of this is opposite over adjacent. That's the opposite. That's the adjacent. That's, oh, I got b again. I haven't got c yet. Maybe I should move to the other angle. Maybe I should try sine of 70. Yep. Did I make a mistake? Oh, thank you. Yep. If you were taking notes, which you should have been, everybody change that B to a C. Thank you very much, Zoe. And now that's why I couldn't find the other one. Maybe I should do tangent. Tangent, TOA, opposite over adjacent. 12.3 over B. And now all I got to do is solve for B. Okay. Lots to learn. It's doable. It is. This stuff's not impossible. But there is a lot to learn. If you decide to fall behind in this class, it will be very painful. Stay caught up. Keep doing your homework every day. When I tell you to memorize something, memorize it. Those triangles we did like 5 times today, the 1 square root of 2, if you aren't able to just rip those off really quick, make yourself some flashcards or something. Because you really need to know all of these things in your head. Because there's hard enough stuff to do without having to struggle over what's pi over 6 again. Okay? All right. And that's all I've got for you for today.